Hello guys, in this video we'll be doing Gauss elimination of matrices using C++. So this is a concept that we usually study at school or college. So I thought let me do this in C++ and let's see how it goes. So I will show you the basic process. So suppose we have this linear equation. We have three variables and we have three equations. And we can express that as a form of a matrix. So the left side containing the equations, let's call that A. We take out the coefficients and put it on one side, and then the right hand side on the other side, let's call that B. So together A matrix and B matrix together, we call it the augmented matrix. It's notated by A bar B. This is our goal. We have to convert this matrix in such a way that this lower triangle becomes 0. From that we can find the individual values of the variables. By that I mean from this we can find the values of the individual variables. So 11z is equal to 22, so z is equal to 2, and from that we can propagate upwards and we can find y and x like that. So let's try to do that in C++. Here we have a basic program. So I am using C++ 23. So some of the features are fairly new, but it can easily be backported to older versions. So let's get started. We need two basic functions. One is to print the matrix because we have the matrix as vectors. They are nested vectors, two-dimensional. We print that, and then we need another function to check if the matrix is in a row echelon form. So we will use this function, and now let's get to the actual part. Okay, so before that you can see I'm calling this print matrix twice. So this is the before version and this is the after version. Here we print the result. Okay, so you can see the variable k. This is like the main variable. This is like the orchestrator of this program. This is like the main stuff that holds it all together. Alright, so now we need a loop. So this loop runs until we find that the matrix has become a row echelon form, and we also add another condition to prevent any kind of errors, which checks that k is less than the size of AB. So by size I mean the number of rows, because this is like a row measure matrix. Okay, now we put an incrementer and a limit. So two things: we don't want the value of k to go about n minus 2, number of rows minus 2, and if it's not hitting that condition, we increase the number by 1. Okay, so you will realize why we need 2 by the end. Okay, now we need another for loop inside this. So think of this loop I as like the variable that goes from top to bottom through the rows. Okay, so I goes from 0, 1, 2, but you may see that the value of I is k plus 1. So initially k is 1, k is 0, so I becomes 1. So I starts from here, row 1, and it goes to 2. If there were more rows, it would go until the end. You get the idea, right? Okay, so inside this we need to get two coefficients. Assuming you know that how Gauss elimination works, we need to make this, for example, taking this row, we need to make this value 0. How can we do that? And we can use this variable to make it 0. So if you see, p coefficient is the value at I and k. I is 1 initially and k is 0. So what is 1, 0? 1, 0 is 3. Next, what is starting p coefficient? This is the value that's just above this value. What is that? A, B, K, K. So k is what? 0. 0, 0 is 2. Now how can we use these two values to make this value 0? So the equation is hear that clearly: 3 minus 2 times 3 by 2. The 2's cancel out, we get 3 minus 3 is equal to 0. So now what? this cell has become 0, and we need to repeat the same for all these cells inside this row. So what do we do? First we check whether this value is 0, because if it is 0 we might run into 0 division error. So this is the multiple I was talking about. So we find the multiple, that is pu coefficient, by starting b coefficient. So this was 3 and this was 2. So we multiply it with the value, that is this one, and we will get 3 minus 3 0. That's what I have written here as an equation. We subtract the row with the product of the kth row and coefficient multiple. So the ith row becomes ith row minus this multiple times the kth row. So that in terms of program becomes a for loop that goes from left to right. So remember, this was going from top to bottom, and this j goes from left to right, and inside that we do the operation. So each cell becomes the cell minus coefficient multiple times this cell, the cell that we have referenced by k, the kth row, and this is the ith row, right? So this is the stuff. So let's try running this. I have the terminal open here, and I have made a simple script to run this. It's basically simple stuff. It uses CMake, and I use Ninja to do the build. And yeah, let me run this. You will see that we get a value like this. This matches the stuff that we saw in the presentation. Now why do we need this value to be 2? Why? Because see, this variable starts from k plus 1, right? This is the index, so it's always 1 minus the normal natural numbers. So k starts from 0, I becomes 1. When it is k is 1, I becomes 2. So that's like the maximum index number we can have for 3-row matrix. Beyond that we get out of bound exceptions, something like that, right? So we limit the value of k, so the value of k does not go beyond 1, right? Yeah, so that's the basic idea. So let's try with some other examples. Now let us try solving some problems that we know the solutions are correct. So let's go to the site. Here we have an example problem. I have put that values inside here. So now let's run this, and we will double check the results. Alright, so this is the answer our program gives, and now let's go to the site and see the result. So 1 minus 2 2 minus 1 3, 1 minus 2 2 minus 1 3, yeah, that's correct. So the second row it becomes 0 1 0 2 1, but we have 0 7 0 14 7. See something different and see something similar. The numbers themselves are different, but you can try dividing this with 7. Divide the entire row by 7, we get 0 1 0 2 1. So that becomes the same as this, and the final row is all 0. So don't worry about this part where we divide it. It's the same matrix anyway, because an extra division does not affect it as far as our case is concerned, because we are aiming for LU factorization and stuff like that, numerical analysis. So this is actually not a problem for us. So yeah, I think this thing is working. So I will see you in the next video.